Okay, everybody, this is Kevin. Thank you for joining. I think we are about to get started here. We're waiting for more people to trickle in, and I think it's about time that we go ahead and get started. So I want to thank everyone who's on for joining so far. Hello, my name is Kevin Karlik. Thanks for joining us. Like I said, we're about to get started. I'm a solution account executive here at Bennett Adelson. Today's webinar, we're going to be focusing on self-service data analytics and leveraging the power of the Azure Data Platform, as well as Microsoft's Power Platform. We're going to be joined by a data architect, Narayan Sujay Sumasakar, who simply goes by Sujay, and he's going to be giving the real bulk of the presentation here. But before we begin, I just want to say a few words about Bennett Adelson for anyone who may not be familiar with us. Bennett Adelson is a professional services organization and an integration partner, and we're focused on Microsoft. We're a Microsoft Gold partner. We have been in business since 1996 and have serviced over 1,000 clients to date. Bennett Adelson is a member of the SharePoint Patterns and Practices Council, and we're also members of the Microsoft Partner Advisory Council. We're Office 365 Technology Adoption Program members, and we're also fast track partners with Microsoft, as well as being Office 365 preferred deployment partners. Bennett Adelson has received numerous awards. We've been selected as Microsoft Partner of the Year. We've been selected multiple times as a top 200 Microsoft partner, and CIO Review had named us one of Microsoft's most one of their 100 most promising Microsoft solution providers. So basically, in summary, I'm telling you, we're an experienced, trusted Microsoft partner. We have the ability and experience to support your initiatives across the entire landscape, including things like business intelligence, the Power Platform, Microsoft Azure, and their clouds, Office 365, SharePoint. We do custom development work. So our team of consultants are truly experts, and they're here to help you should you need it. So that ends my commercial on Bennett Adelson. I'm going to turn it over to Sujay, who it is that you have all really come here to listen to today. So Sujay, I turn it over to you.
Thank you, Kevin. Really excited to be part of this webinar here, and thanks everyone for joining. My name is Narayan Sujay. I'm a data architect. I've been working with Microsoft and Microsoft Azure for ever since I started my career. I started off as a data warehouse developer and slowly branched into the Azure data services and building solutions in Azure. And today I do multi-cloud implementations, focus on data, obviously with the Azure Data Platform, Snowflake, and AWS, Redshift, and S3, and some other services in AWS. So I'll be giving you some flavor of all of that today, based on my experience, what I've done in the past, and also like from from our team here standpoint, like from Bennett Adelson, how we architect solutions, how we help clients, not just from a large business organization standpoint, but also from a small to medium businesses as well. Kind of like our theme today is going to be, how can we at Bennett Adelson, and how do we in the past have helped clients build a robust architecture in Azure, focused on data, and kind of marry the two main platforms together and leverage the best of both worlds from the Microsoft Power Platform and the Azure Data Platform. So today we'll go over some architecture, some design patterns, what are some of the alternatives that you have, how Azure integrates with platforms like Snowflake, which is getting very popular in the data space today, how Azure integrates with another cloud provider like AWS, again, a popular cloud provider. How does Azure work with S3? How does Azure work with Redshift? a few demos around that today, so that you kind of get an idea of what types of architectures we at Bennett Adelson can design and help you with. Our focus today is going to be we're not just talking about large implementations. We're also talking about small business implementations, small to medium-sized business implementations, where we're able to build these data platform solutions without a lot of investment from an IT standpoint, without a lot of downtime in terms of development. We are kind of focused on rapid application development using SaaS platforms, like a very exciting platform like Power Platform. I'm sure a number of people, in fact, not all of you on the call, would have heard of the Power Platform in terms of Power Apps, Power Automate, and Power BI. So all of that, taking all those technologies together, marrying them up with the data platform capabilities of Azure is kind of what I'm here to speak about today, and that's kind of what I have expertise in. One of the challenges that I've had in the past with as a consultant and building solutions is, hey, I'm not a web developer. How do I convince my clients that my solution is an end-to-end solution that's going to solve their problem? So that's where I started with using a lot of some of my solutions in SharePoint, and kind of it is now part of the Power Platform. So I've been very excited to be in this journey with Microsoft. And from a design principle standpoint, we do work with Microsoft, make sure that we are in sync with their vision, we're in sync with the reference architectures, the design principles that they also have to offer. So we're always doing that research as well behind the scenes. Some of the use cases, some of the examples as you see on the slide, a lot of the solutions that we've kind of done is in the accounting, tax, finance, and audit service lines, where you do get these scenarios where there's ever-changing requirements. There's the need for a quick turnaround of a simple data platform application. It could be enterprise level, but most often we've seen, hey, they need it for a specific use case, for a custom use case. So that's kind of the overview of our presentation today. So I wanted to start off with the design principles that we like to always consider when we engage with a client and when we understand the needs of a certain solution. We rely on the Azure well-architected framework. It's basically a set of guiding tenets that can be used to improve the quality of a workload, right? The framework consists mainly of 5 pillars, as you can see on this slide here: reliability, security, cost optimization, operational excellence, and performance efficiencies. Like for me, the number one thing I always consider is security, right? I mean, this could be a thing of the past that a lot of the organizations out there were hesitant to move to the cloud, but obviously that's changing today. But that's something that I always consider when, and we here at Bennett Adelson consider that's our number one priority, to make sure that being data professionals, that the data layer is architected in the most secure manner possible. When we talk about reliability here, what we are really saying is the ability of our system to recover from, we're not saying that, hey, our system is 100% never fails or anything like that, but it's the ability to design some of these architectures and some of these implementations in a way that it could recover from failures quickly and come back to a functional state as soon as possible, right? So that's kind of what we strive to achieve. That could be a simple example, like coming up with a good strategy for your Azure SQL databases, where you design the right availability zones depending on the region where your databases are. So it could be as simple as that. From a cost optimization standpoint, I think we heavily focus on all layers of our platform, right? So in the next slide, I'll show you some of the the different layers. But I think from a cost optimization standpoint, it becomes very important. Here at Bennett Adelson, we not only focus on, hey, do we choose Azure Synapse or do we choose Azure SQL DB or do we choose Snowflake? What's more cost effective? We also go down to the storage layer. We just don't create a storage account and we stop at the point. We actually, analyze the different options that Microsoft has to provide. And there are a number of options that fit almost all needs that are coming up today, right? We look at the redundancy within a storage account, what type of redundancy to choose. We look at, what layers to choose, whether it's a hot layer, cold, or an archive. And I'll go over some of this briefly in some of the future slides, but that's the level of effort we put in, especially towards the beginning of a project in terms of the architecture. Because I think, and we at Binet Adelson think that these 5 principles are basically a game changer for the future of the architectures that we develop. And again, if there are architects on the call here, I think, looking into the Microsoft's, a well-architected framework will really help everyone. So definitely look into that. We'll go over to the next slide here. Typically we start off with the reference architecture from Microsoft, right? I mean, most of our architectures that I'll be going through, I have 3 demos today to show. One is purely Azure, one is with Azure and Snowflake, and one is kind of showing you how Cognitive Services, Power Platform, and Azure Data Platform work together. So that's an exciting demo I'm waiting to show. But at the end of the day, it's all based on this reference architecture. Again, it's ever changing, as you know, with Microsoft, adding newer features pretty much every day, every month. If folks are familiar with Power BI, there's a monthly release cycle for Power BI. So we at Binet Adelson keep up with those monthly releases, not just from a Power BI standpoint, but also from the data services, right? There's a lot of focus that we are doing today, that we are putting a lot of research into how we can integrate more and start using Azure Purview. So if any of you are data professionals in the presentation today, Azure Purview is something that you want to look into. That's the next thing where it kind of makes more sense from a data lake, modern data lake, a lakehouse standpoint, what we're trying to do, discover and govern, basically. But as you can see, I mean, there are mainly 3 layers in here, right? You have your storage layer, you have your processing layer, and then you have your presentation layer. So most of our architectures are based on this. From a Azure standpoint, our universe is around Azure Synapse. Today, I know a lot of folks might be, if you're on Azure, you might be using Data Factory, Azure Databricks, by themselves, and probably even Azure Synapse, right? Formerly called Azure SQL Data Warehouse. But with Synapse, what we are doing is we are helping customers integrate all of that together into one cohesive environment, which means you get to do what you can do with Databricks with Azure SQL, Azure Synapse Spark pools. You get to do what you do with Azure SQL DBs with SQL SQL pools. And you have your Synapse pipelines that you could do similar things that you did with Azure Data Factory. Now, would we be moving towards this more and more? Yes, the answer is a definite yes, right? So that's why I kind of said Synapse is the center of our universe from a data platform standpoint. And what we really want to also help you guys understand from our solutioning standpoint is how can Azure integrate with the Power Platform? So that's the presentation layer, which obviously we'll go through. So if there are web developers in the presentation today, I think you'll relate to this a lot, where data professionals can leverage SaaS services, software as a service platforms like Office 365 and the Power Platform to quickly build some of these custom applications. That doesn't really mean it replaces the enterprise web applications, but it really means that it gets some of the relief to the small and medium businesses much quicker. And then, it provides a stepping stone towards an enterprise solution, right? Kind of moving on to the next slide.
Sujay, a quick question regarding this. So, I mean, you look at this diagram. How does Bennett Adelson and you keep up with constant changes from Microsoft? How do we remain in sync with, Microsoft's vision for the Azure data platform?
Thanks for that question, Kevin. I think going back to the principles that I mentioned, so we always stick to that, right? So whether it's a small business that we're working with to implement this, or with it's a large, obviously we want to keep cost in mind. We want to keep the end goal in mind, right? And then we kind of design some of these architectures. The purpose of us kind of focusing on small businesses to make sure that, hey, some of these solutions, you really don't have to spend millions and millions of dollars to implement it. It's available for everybody, no matter what the size is. Now, the challenge, obviously, Kevin, as you pointed out, how do we keep up with the ever-changing Microsoft technologies, right? I mean, I recently had a challenge a few years ago where I had all my architectures around Azure Data Lake Generation 1. Now, obviously, the push is to completely, turn off Gen 1 and start using Gen 2. So we at Bennett Adelson, we are doing constant research. We are building constant proof of concepts and making sure that our architectures work and the newer tools that are being added by Microsoft make sense wherever it fits in. So that's kind of how we keep up, right? We make sure that we are building the proof of concepts, we are integrating some of these small parts, or maybe even the big part like the data lake during our implementation. So it's obviously our architectures are evolving as the Azure cloud evolves as well.
Thank you, sir.
So a little bit about what, I'm sure most of the audience here are familiar with data warehouses or traditional data warehouses, but today I think the approach that we follow here at Bennett, either for SMBs or LMBs, right, is the modern data warehouse approach. In the modern data warehouse approach, it's basically your traditional data warehouse coming together with the data lake, right? So with the traditional data warehouse, you were, processing relational data, petabytes of data. But with the modern data warehouse, what happens is now you have the ability to process semi-structured data, unstructured data. So you combine the powers of traditional data warehouses and the power of data lake, and you form your modern data warehouse, right? Now, this could get complicated, right? Some of these architectures could get complicated depending on the type of data that you're working with, depending on the complexity of the processing layer, right? So it's really important to get that architecture right initially. So small and medium businesses face a choice when modernizing their on-prem data warehouses for the cloud. They can either pick like the traditional SQL-based solutions for like cost efficiencies, ease of maintenance, and smooth transition. But I think from our standpoint, a hybrid approach is always recommended, right? Easy migration of the existing data state with an opportunity to add like big data tools. So that makes it a robust solution at the end of the day. I do mention here about Azure Machine Learning and Microsoft Dynamics. So that's kind of where, I'll kind of like rely more on my demos to go in depth into it. Because with an architecture like a modern data warehouse, now it's possible to add these advanced technologies to the architecture, like machine learning, like Microsoft Dynamics, the interactivity with Microsoft Dynamics. And obviously the Power Platform, which is kind of today, the data layer for the Power Platform is driven by Dataverse. Going to the next slide here. So some of the potential use cases are, migrating a traditional on-prem relational data warehouse that's like probably small to medium, in the SSIS and SSAS world, right? That could be a use case. That could really work well with a data lake today, making that the traditional Microsoft BI architecture, marrying that with Azure data lakes and everything, that becomes your modern data lake, modern data warehouse, excuse me. And like some of the innovative techniques to interact with the data lake, right? I mean, I'll show you that, there is a ETL approach, there's a ELT approach. There's a really amazing ELT approach with Snowflake that I'm going to show you with Snowpipes, right? So again, you can see that the trend is kind of changing. Like in our architectures at Adelson, we kind of tend to focus on ELT methodologies as compared to ETL. Now, again, we want to keep things simple if the data size and the complexity of the data is not that much, right? So we want to stick to ETLs in that case. But when the complexity grows, when the data size grows, or the nature, like the format of data is different, the ELT approach is a lot better. So ETL, if you're not familiar, it's extract, transform, and load, the traditional data warehousing methodologies. ELT is more like extract, load, and transform. So coming to another specific, so kind of like from the Microsoft reference architecture, coming to one of the architectures that we recommend or we can implement if you have a use case for it, is the SMB architecture. So in this, we obviously have our design principles that we've implemented, but you can see that our focus is kind of ELT, right? We are making sure that once we identify the raw data sources, we are slowly doing the transformation where the data lives. That means we are doing an ELT approach. So there's less chances of data movement. So there's less cost because you're not moving the data. So there's in Azure, if you're not familiar with the Azure storage, costing structure or pricing structure, you're obviously going to be charged for ingress and egress of data, right? The data movement that happens. So with the ETL approach, you're going to probably end up having a lot of costs that you're going to see in terms of data movement. But with an architecture like this, where your data is obviously going to be moved from your source systems, like on the left-hand side, into your data lake, but we limit the data movement by pushing the transform to the data, right? And that's kind of where we are using our Synapse pipelines or Azure Data Factory pipelines to do some of that work. And we rely on serverless, compute, like, the SQL serverless, the Spark tools, and the pipelines within Synapse for the processing, right? In this one, obviously, I haven't, because I'm kind of like, you might not have seen any modeling layer yet, but you'll see that in the next few slides. But here, we are kind of assuming that you don't need a modeling layer due to the data volume, and you can directly consume from a live connection or an import connection through a service like Azure Machine Learning or through the Synapse workspace and push that into Power BI as an example. Thank you. Coming to the next.
Sujay, real quick question. That last slide was for SMB. I don't know if you're going to talk about this or not in coming up here, but what about large size organizations? What would we do differently for them?
In this case, we would be, that's a great question, Kevin, but in that case, depending on the data size, what I would typically do is we would understand the nature of reporting, because in the large businesses, you obviously are dealing with petabytes and large volumes of data, obviously. So I would definitely add a data modeling layer, where there is in-memory capability. So if you're familiar with Azure Analysis Services, which I'm going to show you in the next slide, that's kind of the one change I would say within their architecture as compared to an SMB architecture. So
thank you.
Kind of that's a great question to kind of follow up on this slide, where it's more of a lakehouse architecture. Now before I dive into this, I want to explain what a data lakehouse is. A data lakehouse is basically very similar. It's another, I would say it's another word for a modern data warehouse. So it combines the asset properties of a traditional data warehouse, and it also combines the processing power, the unstructured, semi-structured processing power of the data lake. So in the kind of combining these two together forms your data lakehouse architecture. So you can see that the storage layer is kind of leveraged across the different layers above, which is ingestion, preparation, processing. So in a traditional data warehouse, you can think of it as you have your staging table, you move your raw data from your source systems into a staging table, then you apply a transformation logic on your staging table, and then you go end up reporting that data. But in case of a data lakehouse architecture, you're actually not moving a lot of data. You're actually leveraging the storage layer, and you're leveraging platforms like Databricks. So you can see here the Spark environment that typically Bennett Adelson we work with is Databricks within Azure. And we actually use notebooks, which are code-driven objects within Databricks that can interact with the data lake, do the processing where the data is, and push only the processed data into the relational world, right? Which is a Azure Synapse database or a Snowflake data warehouse. So it kind of saves tons of processing power. It's much faster than a traditional ETL approach. So when it comes to large volumes of data, here we at Bennett Adelson here kind of recommend something like this, right? A rough architecture, focus on doing an ELT approach. And you can see that the model and serve layer should be served right there instead of save. But the model and serve layer is kind of like the key here between the reporting layer and the processing layer. Now, you can rely on direct connections and imports, but that is not scalable. So that is why we recommend Azure Analysis Services to be your data modeling layer, right? So if you're familiar with Power BI, Azure Analysis Services is a subset of Power BI with the new Power BI Premium. So with Power BI XMLA endpoints, which again, I'll show you in a few slides, you can actually process millions and millions of records within the Power BI Premium, workspace, and have your native DAX formulas work on your data. So it's a really amazing technology that we here can help you leverage, or if you're not leveraging today with your solutions, I would highly recommend doing that. Now, this is more of a Microsoft centric, right? So now we also, as I mentioned, we focus on a few other technologies that just very similar to Databricks out there that very well that interact really well with our Azure environment. And that here in this case is Snowflake. So what happens if we took the architecture from the previous slide and inserted a data warehouse like Snowflake? So that's where this comes in. It kind of like shows you how we can. I'll just flip back and forth here between the previous slide. You can see that we've kind of cut down our dependency on Synapse and Databricks and pushed some of the processing and ingestion into Snowflake, right? So it really depends. So if you are a Snowflake shop where you've not invested in Azure Synapse, but you still want to leverage some of the other Azure services, we can help you do that with such an architecture. So the ingestion, the Azure data factories and the Synapse pipelines can be replaced by Snowpipe. Snowpipe interacts very well with the Azure storage layer. And again, I have a demo around that to show you today. And then within the Snowflake data warehouse, you can do the processing. Again, you're kind of, you can go in between. So if you need a Python environment and you need a Snowflake data warehouse to, process your data, I think the combination of working with Databricks and Snowflake is a perfect combination, because one of the implementations that we did here at Bennett Adelson, with this architecture has worked really well. And I was so excited about that one. So I think this is again another design pattern and a architecture that we would recommend, assuming that you want to go with Snowflake as your data warehouse. And this definitely applies for AWS Redshift as well. So I'm gonna, I talked about a little bit about the data complexity. Again, this is where the ELT approach would really help. So the raw data complexity, is what we at Bennett, we focus on that, right? We make sure that we get this part right. This is the starting point of our whole architecture process and implementation process. So we really spend a lot of our times understanding the source systems, the types of different unstructured data that we need to deal with, do we have to process images? Do we have to categorize and classify images? And that really defines what we use upstream, right? So if we are working with a solution where we need to process images and probably classify them as an example, we need to have an architecture that can work with a service like Azure Cognitive Services, right? Because we would love to, in those cases, we would love to leverage what Microsoft has done in terms of artificial intelligence, in terms of without us not rewriting the entire thing and leveraging the API that is available in cognitive services, and then making the solution simple. So that's kind of the idea about this slide here. I think if there are architects out there, definitely reach out, because this is something that you want to focus on initially to make sure that your architecture can handle the complexities of the data. Now, in terms of ingestion, just like the processing, layer, where you have choices between the different data warehouses, the cloud data warehouses, no matter which cloud environment you choose, typically in Azure, we have a number of choices that we evaluate. We sit down with our customers. We understand the current landscape. If it's let's say that traditionally our customers have used, or in this one use case, our customer has used SSIS packages, then that would be a great candidate for using Azure Data Factory, because Azure Data Factory comes with natively built processes to migrate SSIS in a very simple manner. And similar to that, again, going into more of a ELT approach, there are a number of in-database ELT approaches that we can leverage, either using Snowpipe within the Snowflake data warehouse, Polybase within Synapse Polybase, which again is the same concept as Snowpipe, right? You can, with native SQL, you can actually interact with the Azure storage layer to load the data into your staging layers and do the processing on the fly. That means you're actually sending your process, your business logic, your transformation logic to the data sitting in the data lake. Same concept with Redshift Spectrum, AWS Redshift Spectrum. So you have some choices. Again, definitely this is something we have expertise in to implement. So we consider all of these things. And again, kind of adding to some of those alternatives, if it's streaming data, there are a number of solutions as well that we specialize in. We work with event hubs and IoT hubs for streaming data. And also in Databricks, we work with structured streaming. And that is again something we sometimes recommend depending on the use case. There are also, like today, there is some confusion between, hey, when do I use Azure Data Factory versus when do I use Azure, Synapse pipelines? So Synapse pipelines, you can think about that as becoming the superset, or Azure Data Factory becoming a subset of Synapse. So if you've not gone there, I would recommend start using the Synapse pipelines, because they do have all the capabilities of ADF plus more, which is interactions with Spark pools within Synapse, which is a great addition in the Synapse platform. We definitely consider that, right? I mean, we consider, hey, do we need to leverage Databricks more versus the Synapse Spark pools? So depending on this, situation, again, we figure out what suits best in a certain, scenario. Coming to some of the design considerations that we make during the storage layer, we definitely consider, when it comes to semi-structured data and interacting with semi-structured data, for example, with a technology like Azure Cosmos DB, we definitely work with table storage, right? If there is a web application that has challenges interacting with relational data, that's kind of when we use the table storage within Azure. Again, a very scalable, technology there within the storage, within Azure storage. I would definitely recommend reaching out to us if you want to learn more about table storage. We've done a few implementations with table storage, and it's worked out really well with some of the newer web applications that are coming out there, where it heavily relies on schema-less or not binding to the schema, right? It's it's all JSON driven. Primarily, our traditional modern data warehousing solutions are built on top of ADLS Gen 2 with the hierarchical naming conventions, right? We also leverage blob storage if we are processing images and other blob objects. Now, the same architecture can be applied. We do have the expertise working with AWS S3 and GCP Cloud Storage as well. But reach out to us, to understand, if you want to know our thought process in terms of how we leverage the storage and how we consider the different design patterns. Now, one consideration that we make, and here's an example, is in Azure, it becomes really important to focus on, as I've highlighted here, the redundancy. Because yes, depending on the type of redundancy we choose, the cost is structured that way. And also a very important concept that when we go out there and we see clients leveraging, our customers leveraging Azure storage, very few occasions I've seen that there's any emphasis on these types of different layers, right? But I think that is very important, because at the end of the day, not all of your data is always being accessed, right? So it becomes important for us to categorize the data, right? Like your archives, your cool storage, and your hot storage. So we specialize in this, right? We make sure that we identify the data sets or data streams that are hot, that are cool, and that could be archived from a reporting standpoint. So this could save you tons and tons of architecture design time, cost from a storage standpoint, but eventually this can add up if you don't plan for some of these things. Now, from a processing standpoint, yes, there are a number of options. As you see on the screen, you can use Databricks, Synapse, Snowflake, Redshift, or even a simple Azure SQL DB for your processing of your data. Now, when we at Binet Adelson, when we kind of consider this layer, we are actually now dealing with pre-processed data, right? The data that has now left the data lake, been pre-processed through our ELT methodology, and now it's ready for additional processing, as well as getting ready for reporting, right? Before getting pushed into a modeling layer, data modeling layer, like Azure Analysis Services, as an example. So depending on the use case, depending on the size of the data, we pick and choose some of these processing layers. As an example, I would recommend using Databricks if the environment and the data structures are large, and if it's a more of a unstructured data, like you're dealing more with JSON data, semi-structured. If you want to process, like, let's say, documents, and as an example, if you want to do sentiment analysis on survey data, something, a combination of Azure Databricks and Azure Cognitive Services would work really well. And that would be the same with Synapse. Again, Synapse is a newer platforms when it comes to the capabilities of replicating what was done in Databricks and Synapse. So it's a choice there, to see how it integrates. Again, Snowflake and Redshift. Again, if our customers have invested in some of these technologies, I know they're pretty popular out there, we are able to customize some of our architectures to fit even Snowflake and Redshift. Coming now to the data modeling layer. Now, this becomes very important because I rarely see this being used today when I actually go out to clients and I start working with them. And we at Binet, sometimes we're surprised, hey, why are we not considering an important layer like the data modeling layer? Yes, there are capabilities today for a tool like, let's say, Tableau, Power BI, to have a live connection. Why do we even care about a modeling layer? Well, you will have to care, when your data, size becomes very large, or your data is complex enough that you don't want your end users or whoever the users are of the end, data layer are not doing a lot of data modeling with your data, and then hence, getting different types of, reporting results. So that's why, the traditional, modeling from the SQL Server analysis world goes into Azure Analysis Services. And today, Azure Analysis Services is actually going to be a subset of the Power Platform family, which is a subset of Power BI Premium. And what I wanted to, if folks are not familiar with this, maybe introduce some of the folks here to this, was the Power BI XMLA endpoint. Now, this is a great technology. We have been using this a lot in the recent implementations here at Bennett Edelson. This is where you can cut down your cost on Azure Analysis Service. Azure Analysis Services is an expensive service. You can actually cut down your cost on that. You can publish your analysis services models right from Visual Studio to your Power BI Premium workspace. Now with this, you cannot do this with Power BI Pro. You have to have a Power BI Premium workspace. As long as you meet that condition, you do have an XMLA endpoint for every workspace. So you are able to process and publish any model that you make within Visual Studio and analysis services, or even tabular editors. And there are a number of tools out there that you could do. You can publish to XMLA endpoints, and that can be directly consumed by a Power BI dashboard. And then the whole visualization layer can be made really efficient and super powerful. So just a quick architecture again to kind of show you where that fits in. So you might have your relational data sources, again, your curated data or your pre-processed data come in. You can leverage, orchestrate between that, and depending on your hot and cool, you can leverage the blob storage again. And through that, you can push the data through your data modeling layer, which is Azure Analysis Services, or in the previous slide, as I mentioned, the XMLA endpoint, and then push that to Power BI. This is kind of like the visual view of giving you the entire picture of where the Power BI XMLA endpoint or Azure Analysis Services play in terms of the modeling. And basically, that's the key use of a semantic modeling and a powerful visualization tool for simpler, to make the data analysis a little bit more simpler, where you're relying less on your end users to write DAX formulas and so on and so forth. Coming to one of our last layers here, which is the presentation layer, I wanted to focus on the Power Platform, Power Apps, Power Automate, and Power BI. Obviously, we talked a lot about Power BI. I want to focus a little bit on Power Apps, and the Power Apps is where the control is given more and more to our end users, right? So we as data engineers and data science, maybe advanced data scientists have developed the data layers. Now we are in the process of presenting that, or even giving some of the keys to this process to our end users, where it's more self-service. This is where that self-service feature comes in, where they are actually using Power Apps to call pipelines. Either it's Azure Data Factory pipelines, Synapse pipelines, or Snowpipe as an example. They're calling these workflows based on the data that they're uploading or processing, and then getting the answers within Power BI right away. So it's more of an ad hoc data processing as well as self-service data processing. So, and it all kind of fits nicely into the Microsoft ecosystem of tools. And that's kind of what we are also striving to achieve here at Bennett, that we want to make sure that we maintain that Microsoft vision as well as architect, some of these solutions in a way that it is scalable and is as efficient as possible and flexible to change. Now, what is the difference? Like, I just wanted to put this slide out there before I jump into my demos, is because, when we start like this is the key difference we saw with the traditional development process. We have our design sessions. When we go back to the drawing board, we develop it, we test it, and then we release it. So it's more of a rigid process. It takes a lot more time to get your even the first release or like an MVP in front of the customers. Even with an agile development process, it does take a few development, test, review processes and pilots to get to that first MVP, right? As all of you know. But with Power Apps and the Power Platform, it's basically what you see is what you get. So your MVP that you release to the customer gets out faster. So that's kind of the approach that we use. We want to get our first design, our first MVP out as quickly as possible, and also give enough control to the end customers to process data by themselves, not just rely on the backend IT infrastructure to do that, or the backend Azure platforms and workflows to do that. We want to give them that flexibility. So that's kind of like the reason why I put this in here, to kind of give you an idea of how we and Bennett kind of handle that those types of different styles of development. Now, quickly coming to demos here. The first one that I have is like a Power App that we have developed that you can actually call through a Power App that can call a data factory pipeline. So that would typically look like this. So here, it's a simple Power App that I just built for this demo. It's got these large buttons just to show that, demonstrate what happens. So all of these, what we do is we, within the Power Platform, we have built a number of connectivity and connection strings that work together with the Azure platform, and they actually interact with our data pipelines, right? So this is our Azure Data Factory environment. So when we actually click on some of these buttons, and it'll actually start a workflow. So as an example, I'm going to start this, and you can see that this Power App button right here will call a pipeline. So the pipeline's in progress. So actually that triggering happens. So this is something that we can, have end users, call or even start workflows. This is a simple example. Again, going back to this, flow here, what we're doing is we have the data within our, the container is the data lake, obviously Azure Data Lake Gen 2. We then are leveraging Power Apps, and again, we can embed Power Apps within Power BI. So the end users have one seamless, one single, place to come in and process their data. And that actually calls this entire workflow, right? It's calling the pipeline, which is calling code-based notebooks within our data factory environment, doing the business logic, and then pushing the end results back into a Power BI dashboard. With a similar approach, it doesn't have to be all Microsoft, right? Microsoft Azure is very, very flexible. We can integrate with Snowflake. As an example, I'm just use the same Power App here, and then I can actually upload a data file. Like I'm just going to name that because I processed that already. And what happens is it gets loaded, and then in the back end, just to give you a flavor, here we are actually using event subscriptions with the Azure storage. So you can see that the file got uploaded just now, and within Snowflake, the data gets processed. So the mechanism behind this is basically Snowpipe is a technology like very similar to Polybase that works on tables that are linked to it, and then the files get loaded. So you can see there were 24 rows. I can actually load another one to just show you how it works. All right, got that. Make sure it comes here. There you go. And then that kicks off the Snowpipe workflow. Gets loaded. There you go, 27 records. So I'm kind of loading the same data within the file, just changing the names, but you get the idea. In the back end, obviously, without going into too much details, it's the event subscriptions that are actually working. You can see that we have event subscriptions set up in Azure that will trigger the Snowpipe pipelines, and then so on and so forth. Another useful use case, other than Snowpipe working within the data warehouse, is working with Azure Cognitive Services. So once you have your data within Synapse, you can actually call integrate with Databricks and Cognitive Services to do advanced analytics, right? So in this example, I just wanted to show you like how you can leverage Power Apps. So Power Apps is something that you can use. Let's say in this case, I have a simple form. I'm taking a picture of, let's say, concrete here. And then I want to like push that data. As soon as I click save, I want to push that data into a data lake environment or even a relational data warehouse environment like Synapse. So you can see Power Apps is pushing the data to Synapse. That workflow will call, there's a trigger that we've built in that will call the Databricks notebook, and then in turn call the API, the Azure Cognitive Services API, and do image classification. So in this simple example, you can see that the images that the Power Apps took, we pass it, and this is one way. I just wanted to show you what happens in the backend. It kind of goes through every image and does the classification of the images. So we kind of specialize in some of these things, and these architectures help us do that. So wanted to with all the theory that I talked about, wanted to show some of the demos that actually makes these things kind of come together. So I'll stop there and see if anyone has any questions, and give it back to Kevin.
Yeah, thanks, Sujay. Does anyone have any questions for Sujay? Because we want to make sure, I know we're up here against the hour, but if there are questions, we'd like to make sure we get those answered. Okay, well, if there are no questions, or if you think of some questions, feel free to send them over to us and we'll get you the answers based on everything Sujay was showing here today. I want to thank everyone for joining today's session. We will post this webinar to Bennett Adelson's website within the next couple of days. So it should be up there, I would say, by Monday. If anybody would like to have any further discussions around this topic or any other topics, please reach out to myself or Brian Conley or Grant Margaret, the account executives over here. We can assist you and get the right specialists on the line to help you out. So we'd look forward to doing that, and we'd be honored to do it if you have any needs. So with that, this concludes today's sessions, and I want to thank you all for spending time with us. Thanks.